Lesson 2 of Chapter 5 deals with proportions. Let's first define what a proportion is. It's an equation stating that two ratios are equivalent. The reason it's an equation is because it has an equal sign. Anything with an equal sign is considered an equation. So showing that two ratios, like the ratio 2/3 equals 4/6, we just set up a proportion. Something to note, or the meaning of the word proportional. When you work toward a goal, your success is usually proportional to the amount of work you put in. An equation stating that two ratios are equal is a proportion. Two quantities that are proportional are in a proportional relationship. So, tell whether 6:4 and 8:12 form a proportion. We're going to say yes or no and why. So I want to know. So we're going to set it up like a proportion. We're going to put 6/4 to write our ratios as fractions. Does that equal 8/12? Yes or no and why? This is a 4. Well, I know that 4 times 3 gives me 12. Is 6 times 3 8? No, right? So are these proportional? Are they equal? No. They're not proportional because they are not equal. Another way to decide whether they were equal or not, maybe you don't see a relationship like times 3, you can always simplify. Like 6/4, I can divide both of those by 2, and I would get 3/2. 8/12, I can divide both of those by 4, and I would get 2/3. Does 3/2 equal 2/3? Are they the same thing? No. So when you're trying to figure out whether it forms a proportion, you're deciding yes or no, are they equal? So no, because they are not equal. So go ahead and write that nice explanation. Because they are not equal. Determining whether two quantities are proportional. So we're going to tell whether x and y are proportional from this table. Look at that table. Does x to y, would all of these be equal? So there's a few ways we could do this. You could just choose 2 of them, like I would choose the ones that aren't fractions. You could write them as x/y. X/y. Does that equal this one that is x/y? Would they be equal to each other? Yes or no? Maybe you're thinking, okay, 6 times 2 is 12. Is 1 times 2 2? Yes. So you're thinking they're equal. Maybe you know that 2/12, I can divide both by 2. I get 1/6. Does 1/6 equal 1/6? Yes, so they're equal. Another way to show that a table is proportional or equal, or try to figure out if it is go ahead and just look at each relationship. You don't have to set it up as a proportion. I know 1 times 6 gives me 6. I know 2 times 6 gives me 12. And go ahead and just check with all of these. If I multiply this by 6, does it give me that y value? Well, I know half of 6 is 3. So far, all of these I can multiply by 6 to get the y. And then you can check with that last one as well. So yes, and then your y is because they're all equal. So they're proportional. Go ahead and try it with this table. Maybe you want to pause and take a look. Now be careful. These are your x values and these are your y values. So we're looking down. 1 to 12. Is that equal to 2 to 24, 4 to 48, 6 to 72? So maybe pause and say yes or no and why. So remember, from a table, you could write all of these as fractions. Like this would be 1/12. This would be 2 over 24. So you could write them all as ratios or fractions. And then in order to decide whether they're proportional, you want to know, do they all equal the same thing? Can you simplify all of these to the same fraction? 1 over 12 is in simplest form. 2 over 24, I could divide both by 2, I get 1 over 12. So I'm just deciding, can I simplify everything? I could divide by 4, I get 1 over 12. And the last one, I can divide each by 6, I get 1 over 12. So see how I was able to simplify them all down to 1 over 12? So are these proportional? Yes, because they're equal. Awesome. All right. Proportional relationships in word problems. First one, you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So my first, I completed 4 laps in 2.4 minutes. Is that equal to completing 16 laps in 12 minutes? So essentially I want to know, do these equal the same thing? Maybe can I simplify them to the same thing? Something of that nature, right? Well, I want to show you something. If I multiply 2.4 by 10, that gives me 24. See how I can just move that decimal to the right? That means I multiplied it by 10. I'm trying to get some easy numbers here for us to think. Now if I do the top by 10, that would give us 40. So now this is 40 over 24. So I'm going to try to see, can I get this denominator to 24 as well? Well, yeah, I can multiply it by 2. So that would give me 24. What's 16 times 2? That would be 32. Is 32 over 24 equal to 40 over 24? No. So another way to decide whether or not they're proportional is see if you can get them in this with the same denominator, right? Just like up here, we got them all to a denominator of 12, which meant all their numerators were 1, they're equal. Down here, I tried to make it a little easier. I made them all 24. You could have tried to just simplify them all or find the unit rate for each of them to help you. But no, the number of laps is not proportional to my time. And let's do my second word problem here. You read the first 20 pages of a book in 25 minutes. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? So let's see. I did 20 pages in 25 minutes. I want to know, does that equal 36 pages in 45 minutes? You could find the unit rate. You could try to get them to the same denominator. There's a lot of options here of what to do. You could simplify them both. So maybe, any of those are a good point or a good way to start. So maybe we want to, try to simplify them. I can divide 20 and 25 by 5. That would give me 4 over 5. 36 and 45, I can divide both of those by 9. And that would give me 4 over 5. So do you see how I just simplified them? And now look, does 4/5 equal 4/5? Yes. So are these proportional? Yes. I'm reading at the same rate. Now that was just one way. You could find the unit rate. You could get them to have some sort of common denominator somehow. I don't know if that's the easiest way here, but yeah, try to simplify, try to get a common denominator. You could always find the unit rate. Remember, unit rate means you're getting the denominator to 1. So whatever you prefer, you're just trying to determine, can I get these fractions? Are they equal to each other? Are they equal ratios?